Hi, I'm Stephanie Belloris.
And I'm Keith Johnston, your host for Forrester's podcast, What It Means, where we explore the latest market dynamics impacting executives and their customers. Today, we're joined by Vice President and Principal Analyst Paul Miller and Senior Analyst Stephanie Liu to discuss the differences between digital doubles and digital twins. Welcome both.
Good to be here. Thank you very much for the invitation.
Thanks for having us.
So these are two very exciting topics because they're two tech trends that are happening that sound alike, but are very different. They have different users, different technologies, and different goals. And in fact, the idea of digital twinning is not new. It comes back to the 60s when NASA used these techniques. So in this episode, we're going to focus on how digital doubles differ from digital twins. So let's start out with a basic definition of the two technologies and how they're used today, starting with you, Steph. Talk to us about your newest research that we featured at CXNA about digital doubles. What are they?
I'll start with the definition, but I also want to dive into the how we got here. So a digital double, in short, is an algorithm that the consumer creates and the consumer owns. So the idea here is it will interact with other algorithms, with other brands, retailers, search engines, to tailor the outputs and digital experiences based on your own goals and values. Now that sounds lofty, but I think what we're seeing is a lot of frustration with the way algorithms work today. They are tuned to business outcomes. They make a lot of inferences or assumptions on who we are or what we're trying to accomplish. And it's a really frustrating experience when they get it wrong. And we are seeing the rise of AI agents broadly, and digital doubles is one flavor of those.
Paul, can you walk us through now what a digital twin is?
Yes, digital twin. So we have a short, punchy definition, a digital representation of a physical thing's data, state, relationships, and behavior. And the important word I said in there was near the beginning, physical thing. So these digital twins have a physical twin. They always have a physical twin. And we'll dig into some of why that matters and how it helps to differentiate from digital doubles in a bit.
So, Steph, you mentioned that you want to talk about how we got here. And I think it's really important because, Paul made a distinction about the software emulating this physical thing, whereas algorithms are constantly evolving and interacting with other algorithms. So why was it so important to do this technology now? And where do we think that it's going the fastest? Like, where is this going to show up, the quickest?
There have been, I don't know if I should call them complaints or critiques about the algopocalypse. And I think one of the areas where that's most painful is in search, especially with Gen AI now and all of the hype and resources that are going into it. There's a debate on whether it's actually making search better or worse, because you have to do more sifting of what the search engine is producing to verify that it's accurate, that it's using sources that you trust and that you think are quality, because your definition of accurate and high quality may differ from the search engines. So that was one of the motivations for doing this research now was going through just the complaints about algorithms and how they're everywhere for sure. And in many cases, they work to our favor, but there are also instances where they're harming the customer experience.
So, Steph, to be clear, the digital double is very consumer-oriented, consumer-led, and probably quickly becoming AI-driven like a lot of things, whereas the digital twins is much more industrious. And again, Paul mentioned physical. So just as a point of clarity, Paul, where's the digital twin really headed? How is it evolving as it relates to AI and such?
So the digital twin has been around in its current form for about 10 to 15 years. You mentioned at the beginning that NASA were talking about them in the 60s. They were talking about twins, but they weren't digital. There was no digital element to them. So remember, everyone who's seen Apollo 13, Houston, we have a problem, all that stuff. There were engineers on the ground with an exact copy of the spacecraft that was in orbit, and they were pulling out breakers and flicking switches, trying to find a way to solve the problem. That was a physical twin. You now take the same ideas into the virtual world, and instead of having to have a physical copy of every machine, you can simulate it in software, and you can understand what might happen, how something might perform in a storm, deep under the sea, in unusual situations of various kinds. And you're taking an understanding of the physical properties of the asset, you're taking detailed CAD models and rules and all the rest of it around how this thing should perform in the real world. You're taking a load of sensor data coming off IoT sensors and other inputs, and you're putting all of that together and building a model to understand how this thing will actually behave. And that allows you then to project forward into a future state, or perhaps a distant state. How is the aircraft I am twinning operating somewhere out over the Atlantic right now? Because I'm not there. I can't see it. So how can I compute what it might be doing? And, there's a whole lot to dig into there. You asked how this is changing. The way it's changing mostly is that a lot of these models started life as very asset and vendor specific. A company making a robot makes a digital twin of that robot. Another company making a digital twin of a conveyor belt makes a digital twin of that conveyor belt. You're the poor factory manager who's trying to run a factory that has conveyor belts and robots in it. And the twins, until recently, didn't do a very good job of talking to one another. So you had to look at them as separate, distinct things and join them together in your own head. We're now getting to the stage where we're starting to do that joining together in software and build complex or composite digital twins of an entire factory, for example.
So it's interesting. It sounds like, one distinction that we could make as well is like digital twins really have to be identical. They are completely identical. It really is a twin. Whereas a digital double, it doesn't have to be identical. This is an intermediary on your behalf. It's meant to reflect your preferences, but it doesn't necessarily have to perfectly reflect you.
Yes, a digital twin absolutely has to be identical, but it may not be complete. It may not be an identical copy of every attribute of a machine or a set of machines. It may just be a twin, for example, of the gripper on the end of a robot, because that's where you consistently have a problem. So you're building a twin of that to really understand the gripper. You might not build the hydraulic system and the other motors and the paint color into your digital twin, because for your use case, it doesn't matter. But yes, for the stuff you're twinning, it absolutely has to be high fidelity, physically accurate, and complete.
That is a great distinction. Steph, in your research, you talked about the possibility of having many digital doubles.
Yeah, it's a matter of what you want to present about yourself in the context of who your digital double is interacting with. The examples I give are there are things I share, for example, with my doctor's office that are very relevant for keeping me healthy and meeting my wellness goals, whatever that may be. Those are not things I'm going to share with my coworkers in a day-to-day business conversation, right? What we present, how much data we're willing to share is heavily influenced by the context of who you're sharing it with, what your relationship is, how that data will be used. And for that reason, I think digital doubles will be similar. We'll create multiple digital doubles depending on what data we need to share to get a task done or to meet our goals.
So now that we have the definitions established, I just want to ask the question, like, how commonly used are these industry-specific standard terms? How often maybe are they confused? Because we've talked a lot about software, and when you build software to emulate things, there probably could be a lot of blurry lines between these two concepts.
I'll jump in first and then we can see what Steph thinks. But I think as I look at it from that asset-intensive industry perspective, there's a broad understanding of digital twin as a term, broad understanding of more or less what it's for. You do have some vendors who will talk about a virtual twin instead. and say it's somehow better or different than a digital twin. So far as I can tell, it's just a vendor take on a digital twin. The bigger problem I think I see in manufacturing and moving out beyond that is sectors like financial services, sectors like healthcare, seeing this notion of a digital twin and thinking, oh, I like that, I could use that, and applying something that's fundamentally grounded in a real thing and applying it to intangible stuff. I had one conversation recently with a financial services client, and they wanted a digital twin of the process of applying for a mortgage. And you can probably imagine how that call went. But I don't think I told them what they wanted to hear. Let's just put it like that.
So it has to be grounded in a physical asset. One thing I was thinking about, and actually I had a client ask me about this recently, is can you create a digital twin of something to be built, like a proposed physical asset? And this actually came up for a client who was thinking about a new building and wanted to understand what the future energy requirements were going to be. They were very concerned about sustainability. So can it be for something to be built in the future to kind of understand it now ahead of time, what those requirements might be?
Yes, so long as that is grounded in real things that already exist elsewhere. So, for example, one large manufacturer built a digital twin of a factory they wanted to open in China. And the inputs into that was data from all the factories they already had in China. And so they were optimizing and understanding where to improve things, where to improve the flow of air or water through an HVAC system, where to improve how robots move through the factory floor, that kind of thing. So they were taking inputs from the real world and extrapolating from those to understand what this future state factory should look like to make sure it was even better.
So as long as the components exist in the real world, they don't necessarily, it doesn't have to be an identical factory, but as long as those components, if you understood, like you mentioned, like airflow, the materials, you could take those current examples and then extrapolate it into the simulation to give you a sense of what will happen in the future.
Yes, absolutely. And that grounding in physics, understanding how metal heats up when you apply heat to it, how heat is transferred from water as it moves through a space, all of that kind of stuff. There are rules and laws about how that works. And you apply it to your digital twin.
So insurance companies have looked at where houses are located and then how the environmental things may impact policy or whether they insure it or not. So is that digital twinning or is it just a simulation? Because you guys are talking about the very tangible inside assets of a factory, but what about all the things happening around it? What's that conceptually?
I think if we look at an example like flood risk modeling for insurance, that's a simulation. You're taking a detailed model of topography. You're taking detailed understanding of how water flows through a space. You have a map that shows where the houses are, and you're basically raising the water level in your simulation to understand which of those house plots go blue. And that's a risk. I need to do something about that. And I might either say, I'm sorry, I'm not insuring your house because it goes blue. Or you might say, I've got a contractor who can come and, put a wall around your plot. And that wall will be 50 centimetres high and it'll be waterproof, and that will keep your property safe from flooding. If you agree to do that, I'll lower your premiums.
Yeah, the insurance industry has been really good at catastrophe modeling for a long time. And then, interestingly enough, now enterprises have access to similar capabilities with climate risk analytics. But I do kind of wonder in my head now that we're talking about it, could you ever bring these two together? Which is, if you were an enterprise, could you use climate risk analytics to predict future sea level rise, variations in heat temperature, and then could you apply it to your digital twin to then understand how you might actually retrofit your building to withstand it in some of those scenarios? So is there potentially a marrying of the two?
Totally, yes. If you have that detailed model of the building and you understand how it warms up and you understand how air flows, all that, then yeah, simulate raising the temperature by a couple of degrees. Simulate torrential rain falling into the goods yard, and are your drains able to cope with carrying that water away? Yeah, absolutely, we see that kind of thing building up in this space.
Yeah, I can imagine because between computational capabilities and AI, like these technologies will just keep evolving. Speaking of, Steph, Forrester introduced the personal digital twins back in 2018, but you revisited this research and took into account all the things that have happened since then and created a new name. Is this the name that's going to stick? Is it going to be well known within the consumer space?
I hope so. One of the things that was very evident when I started this research was we need to rename it because digital twins have become a very buzzy thing. As Paul has walked us through, they are not a new concept. They are rooted in some fundamental principles of manufacturing, right? And the needing the physical replication of a thing. That is the foundation of the digital twin. With personal digital twins, it was supposed to be like okay, we'll take that concept and make it a digital sort of augmentation of who we are as people and who we want to be when we're recognized in digital environments. But it didn't really translate. There are just too many complexities of being a person, and you don't always need a literal copy of who you are physically. The physical proportions of who I am are not important relative to what I'm trying to accomplish or what products I'm likely to buy and those kinds of digital data-driven inputs. The other challenge is after the research published, I had a couple tech companies say, oh, we already do that. We've got it. And I click on the press release or the website they send me, and they're using digital twin, but also not in the way that Paul means. In a lot of cases, I see this from the marketing side. It's customer analytics companies who are calling a digital twin really a way of, it's more of a simulation of how a experience will impact a customer journey or trying to predict how changing a segmentation will impact like a message or campaign performance or response rates. It's really just modeling and again, trying to predict how changes in messages, offers, A/B testing, etc., will impact outcomes. It's still not digital twins in the way that Paul is describing. And so for that reason, just given how much noise is already surrounding digital twins and how drastically different the use cases, the purpose of a digital double is, we had a sit down, we thought about it, like, what are we going to name this? Because it needs to be separated from the digital twin terminology.
Hearing you explain that just, reinforces why there's likely any one person has multiple digital doubles, because the way you might behave when you're buying a car or a house is very different than buying a pair of shoes online,
I think the key too is, I could be wrong about this stuff. Primarily, are you controlling your digital double? It's always controlled by the individual. Like you're controlling all the preferences, its behaviors, how you'd like it to transact on your behalf.
Yes, and that's what makes it unique is algorithms today are predominantly created by businesses driving business outcomes. This is one where the consumer is designing it. There is going to be obviously some reliance on business and probably some pieces of big tech to actually host the digital double to support the underlying infrastructure. But in terms of controlling what data goes into it, what it's tuned to accomplish, that should sit in the consumer's hands. It sounds futuristic, but if you look at the way preference centers work today, think of it as an evolution of a preference center. You can go to, for example, Sephora and tell it some pretty detailed information about who you are and what you're looking for, your skin tone, your skincare concerns, your hair type, your hair color, and so on. And all of that will impact the products Sephora shows you, which, if you're looking at a new foundation you've never bought before, which shade should be the best match for you. It's very much, I want to tune Sephora's product recommendation algorithm to my inputs. And if we take that concept and expand on it, throws a ton of AI capabilities into it, that's where the digital double is heading. It's like if you could build your own preference center of here's the information I want to share with a retailer or a brand. Here is the information I want it to know about me so that it can give me recommendations that are much more likely to fit my needs, work for me, meet my budget, whatever your constraints are.
I love the privacy angle, like the empowerment it can give individuals for privacy. I mean, this way, we know based on our privacy segmentation that, there's a range of privacy preferences, like how much people are willing to share in exchange for values. So it almost seems like this, again, allows you to express your very particular privacy preferences. I'm almost wondering if it's really beneficial for the businesses too to support this as much as possible, because they can always say they're meeting exactly the needs of the consumer, as opposed to having broad policies that try to cover everybody in a peanut butter type approach, but really don't recognize individuals' own desires for privacy and value exchange.
Yeah, one of my predictions for the digital double is that it will actually be companies who are driving adoption and implementation, because for them, it gives them access to really high quality data, right? This is data that they can hopefully get if they're inferring it based on consumer behaviors. But take the car shopping example. If you walk into a dealership and say, these are the exact kinds of parameters I'm looking for, and I'm the kind of person who will only shop for a new car when my current one is on its last leg. I am not someone who upgrades to the latest and greatest every 2 years versus, I am someone who upgrades, right? It changes the entire context of how you pitch the car, how often you try to upsell, what kind of service package you're going to try and cross-sell, right? It changes all of that, and it gives brands a much easier way of understanding the best way to talk to you, the best products to promote to you, and so on. So it also enables you to do really rich personalization in the ways that marketers love to talk about, but in a way that doesn't violate privacy, because this is all volunteer data, right? You are getting this really rich contextual information straight from the customer or prospect. And I think that upside will be so significant that we'll see some incentivization of exclusive pricing or exclusive discounts if you have a digital double set up.
These are both fantastic explanations. I think the audience is definitely going to know what these are now. So maybe let's focus on the near term, because you can see how, like I said earlier, with compute power and AI and all the new things and the evolutions of these technologies, where the future, the possibilities of these technologies is pretty obvious. I actually think what's not so obvious is, like, what is the state of these technologies right now? And maybe we'll start with you, Paul, because your timeline is very different than what we're talking about with digital doubles.
Yes, it is. I mean, they're around, digital twins are around, they're being used. As I said, they're mostly used today by vendors, by the companies making machines, and they are selling or renting the machine to their customers, and a digital twin comes along with it. And that digital twin fundamentally is about allowing the original equipment maker to keep an eye on their product, to understand how it's actually being used, to understand when it's perhaps the time to pick up the phone and say, Keith, that compressor you've got, it's running a little hot. What you need is an oil change. And for special for you today, $50, and I'll send someone over to do it. That kind of thing. But also gathering information on how these products actually work in the real world to inform the design and manufacture of the next generation of the product. Really understanding how these things are really used gets quite interesting. And then, as you push out a little beyond that, seeing lots of interest in things like energy use, building digital twins to understand how these assets consume power. Because, think back 18 months, 2 years or so ago, when energy prices spiked all over the world. And you had manufacturers saying, it's no longer cost effective to run our machines. We simply can't afford to stay in business. So it became very interesting then to build these models and to understand how different assets consumed power, to allow you to make choices about when you ran them, what you did with them, and when actually the right choice was to shut the machine down and wait until power prices fell. So seeing a lot of that kind of thing carry on now as well into more sustained, more sort of programmatic approaches to thinking about power use, emissions use, raw material use across these assets.
And it's historically, as you mentioned, been manufacturing, and heavy industry, if you will. Do you see that expanding in the future to different industries?
Yes, I mean, we certainly starts off in asset-intensive industries, so manufacturing, oil and gas, chemicals, those kinds of things. Very clear and obvious step into buildings, building management, controlling the HVAC, controlling cooling, anticipating when the sun is going to shine in your south-facing window, so maybe you should proactively close the blinds before the room gets too hot, that kind of thing. But also then the transportation sector, thinking about how transport grids work. Deutsche Bahn in Germany, for example, is talking about building a digital twin of the rail network. They're not there yet, but they have a very clear vision and a very clear understanding of what it would help them do to increase efficiency, to improve maintenance, and to deliver a better customer experience for those passengers who are waiting for a train on the platform.
And Steph, I mean, Gen AI has probably opened up a whole host of opportunities for digital doubles. But it seems to me, as we were discussing just a few minutes ago, that global privacy, regulation, and a whole host of things that are not technology related might hold back the digital double a bit. So what's the status of the digital double, like right here and now, or maybe in the next 12 to 24 months?
Still a dream. They're not real yet, but I don't think they're too far off. As I've said, we have some frameworks just in the way preference centers are built and operated today. And if we evolve that, apply it to an open ecosystem. So instead of telling just Sephora my beauty preferences, I can tell all beauty retailers that I shop with my beauty profile. That is essentially the digital double. Where I think they'll evolve, of course, there's going to be the AI and the tech component, but I also think their use cases will evolve. So coming out of the gate, it'll be some low-hanging fruit of tailoring product recommendations or search results, because it's something where, as a consumer, you can understand transparently, here's the information I provided, here's how it's impacting the search results or the products that I'm seeing. It's also low stakes in that the human is still in the loop. You are essentially reviewing the recommendations. You get to pick at the end of the day which product you choose to purchase. As we get more comfortable with digital doubles in terms of setting one up, using it, seeing what it does, I think we'll see some more automation where the human is removed from the loop for low stakes purchases. I always use the example of shopping for toddler shoes. I've got a 3-year-old. He grows pretty quickly. I hate having to overhaul his wardrobe every few months because he's grown another size. If my digital double could do that and, for relatively cheap clothes purchases, I'm not going to be too worried about it going berserk. That said, I think there will always be some areas where you don't want your digital double to actually transact for you. Things like buying a mortgage or a new car, right? Where there's a lot on the line. That's where you can set it up as, just pull quotes or just pull recommendations. I still want to make the final decision. With Gen AI, I also think there's opportunity there of essentially having your digital double do the prompt engineering for you so that you can tailor the outputs to meet your needs and your expectations. But, if I could tell ChatGPT, for example, I need you to parse this new privacy law in Quebec. I read privacy laws all the time. Please don't give me the 101 level. I need something a little bit more thorough. It would make ChatGPT that much more useful for me.
Well, this is such a cool concept, and there is so much more research to be done for sure. I thank my co-host Stephanie Dolores, and thank you both for giving such clear explanation on such a complex topic. Thank you.
Thanks so much.
And thank you for having me anytime.
If you like what you heard today, subscribe to Forrester's What It Means podcast on Apple Podcasts, Spotify, or your favorite podcast player. To continue the conversation, follow Forrester on LinkedIn or drop us a note at podcast@forrester.com. Thanks for listening.